safe. Everyone I know is safe. You're not, no one in here is allowed to.
All right,
No ventilation
so
in this room.
before lunch, we have, all right everyone, I know you're all excited. Thank God we get to come back to math class. But we have graphed this thing, and we are now ready to answer all the questions. So I erased some of my stuff over there. What's our domain?
Negative infinity to infinity.
Exactly. Would everybody agree with that? We're going side to side here. What's my range?
Is this where it starts?
0 to 6.
0 to 6, and there are no brackets because 0 and 6 are the asymptotes. Okay. Am I continuous?
Yes. On hold the
Whole thing. The entire time, there's no breaks in it. Increasing or decreasing?
increase.
This one is also increasing.
On hold
The whole domain. Does it have any symmetry?
No.
Actually, guys, it does have a point of symmetry. It's not on the y-axis, but there's a point of symmetry right here. I wonder if we could figure out where that was.
Wait, how would you know if it's symmetrical from just looking at it though? Isn't that the first thing?
That's a hard question.
Well, don't trust my picture, take my word for it.
Would you plug in 3? What?
Plug in 3. Now, wait a minute. Why does she want to plug in 3?
Because that's what the y is.
Because that would be halfway in between, right? So, stop and think about your cubic function. Now, it's vertical, but this is a point of symmetry here. This thing is symmetric about the origin. So we have the same shape turned on its side. This isn't the origin, obviously, but if that's going to be a point of symmetry, then doesn't that y coordinate have to be 3? Okay, somebody help her get why the y coordinate would have to be 3. If that's the point of symmetry, which is right in the middle of the picture. What's right in the middle, Moran, of 0 and 6? There we go. All right, so could we find that point of symmetry? Now, I'm going to back up. Peter says, oh, Miss Ford, please no, let's just move on. Here's the deal. This does not have any of our special symmetries. So when we talk about x-axis, y-axis, origin, identity, it doesn't have any of those. It does have its own special points of symmetry. And you can find that, right? And we need practice anyway, doing math. So let's go ahead. Let's finish this so I can erase it, and then we'll come back and find that point. Is it bounded? Above and below. So above at y equals 6 and below at y equals 0. So this is an example of a truly bounded function. Bounded means below and above. Right? This one is. So that's a bounded function. Does it have any asymptotes? Yes, it has 2 of them. Y equals 0, y equals 6. Does it have any extrema?
No.
No. And let's talk about its end behavior. What happens as we go all the way to the right? We approach 6 from the bottom. Very good. We go 6 from the bottom. What happens as we go all the way to the left? 0 from the top. All right, so we took care of what was required there. So I'm still fascinated by that point right there, so we're gonna find it. Okay, so we're all in agreement that y is gonna be 3. So our equation will look like this. At least this one doesn't have all those big numbers and crazy decimals. This is like our when's the population gonna be a million problem. So what are we gonna do to get started here?
Can you multiply by 1 plus 2?
Bring this guy over and distribute. So 3 times 1, 3 times 2.
Would it be easier to put the negative x on top?
You can't because it's hooked to the 2 and hooked to the plus sign.
Okay.
So it can't move. It can't move.
Could you divide that whole thing by 3 right now?
Both sides by 3?
Yeah.
I absolutely could. I'm not going to. It wouldn't hurt anything. And eventually that's gonna wash out right here in my next step anyhow. But yes, you could. Multiply both sides by a third, basically. All right, now what? Subtract the 3. And then divide by 6. So here, Lucy, I'm gonna get my 0.5 right here. You would have gotten that earlier because you wouldn't have all the 3s and 6s. Now what? We're gonna take the natural log of both sides. That's gone, so negative x equals ln 0.5. And x will equal negative ln 0.5. Now, the work we just did was exactly like the one we did with the population of a million. The numbers are easier, but you did the same math. Those are exactly the steps you did. So negative ln 0.5. Did you get 0.693?
Yes.
So this is the point, 0.693 comma 3. So in other words, if you could flip across that point, the curve is gonna be the same.
Is any logistic function gonna have symmetry?
We have a point of symmetry
Point of
like that,
symmetry.
yeah.
Okay.
Not necessarily that point, but a point. All right. Good deal. All right, one more population problem, and then we're gonna be done with this section. Here we go. Using 20th century data, the population is this. Make sure I get this copied right. I really don't like this. All these decimal points and little numbers. 0.0305.
Is this 035?
05. Did I get that exponent right?
Yeah.
What was the population of New York in 1850? What are we gonna do?
Plug in 50 for
Plug in what are we plugging in?
50.
50? So in other words, we're gonna find P of 50. So I'm not gonna recopy all that. I'm just gonna type it into my calculator and put a 50 there. Do I need logarithms to do that? No. I need logarithms when I have to find my time. But if I know my time, I'm just plugging it in. So put a 50 right there and type it in. Now be careful as you type it in. Probably wanna put your denominator in parentheses. 19.875 divided by parentheses, 1 plus. You know how to get E on your calculator?
Second ln.
Yeah, say second ln.
Just x. Yeah, you do, but it's 50. Times 50. What do we get? I got 1.7.
What'd you come up with?
1.79.
1.79. So what does that mean? Our answer is, it said, oh wait, 1.79 millions. Did you notice? P is the population in millions. So this is 1.79 million.
So it's dividing. Divided by the first.
Is that all right with everybody?
Would you?
All right, we're not gonna do B. B is gonna be the same thing, right? Except what are we gonna plug in? 210, right? Same exact thing. What is New York's maximum sustainable population, also known as limit to growth? 19.875 million people. If you were to graph this, your top asymptote would be at that number, right? So the population would be. Okay? All right, finally done with 3.1, so that'll be due on Friday. Hopefully you've already started it. If not, that's okay. I want to do a couple of these, and I'm going to turn back to quizzes and answer any questions you have. But I want to go ahead and get started on 3.2. Would you agree that question A is exponential?
Yes.
Yep. What's the initial value?
782,248.
What is the rate of growth or decay? Now be careful. A base of 1.0136 is 101.36%. Would you agree with that? Now, a population that stays at 100% means it's not changing. What's happening to this population? It is actually going up 1.36%. So the rate of growth is 1.36%. If the population of Cathedral High School is 1,100, and next year it's 100% of 1,100, it's still at 1,100, right? But if it's gone up, then that percentage is going to be more than 100, and the amount that it's more than 100 is what its growth is.
So our rate can't be over 100, right? Like when we're finding the rate, it can't be over.
Well, it probably won't be, but if a population doubles, then it would be 2.00, it would be 200%.
And then can it go below 0?
No,
No, so we can't have negatives.
can't be negative. Can't be negative. So you might say to yourself, well, let me look at the next one. Yeah, so let's finish this one. The initial value is the 782 number, and the rate of growth is 1.36%. Now look at the next problem. What's the initial value? 1,202,000. But notice this base is 0.9858,
Decay.
which means it's decaying by what percentage?
12.5.
1.42. Because 100% or 1 means stable, means you're not changing, right? Multiply by 100%, multiply by 1, you stay the same. Here we are multiplying by 0.9858, which is less than 1, right? How much less than 1? That is your rate of decay. How much less than 1 are you? 1 is stable. Whatever you're above 1 or less than 1, that's how you're going your decay. So Peter did the subtraction and got 1.42%, 0.0142. So you can say 0.0142, or you can say 1.42%.
Do it have to be negative 1.42?
No, the rate is not gonna be negative. When you multiply by a number less than 1, aren't you automatically gonna get smaller?
Or you can do
Wait, it's like being at 1.42%?
the other one you're just taking out.
0.0142, so 1.42%. Alright, number 2, do the same thing, but now you're writing your own. Write the exponential function, so it looks like this. This is what it's gonna look like. And initial value is 120. Right? Initial value. And a growth rate of 8%. So you're growing 8%. You're 8% more than 100. So what's gonna go right here?
1.08.
1.08. However much you're more than 1 is your growth rate, however much you're less than 1 is your decay rate. So what would this look like if it were decaying 8%?
0.92.
120 times 0.92 to the x.
Yeah.
Now listen to me, because this is a very common mistake. You're gonna be reading along in a problem, it's gonna be in a million different problems, comes along and it says all of a sudden, the population is shrinking 2% per year. Do not multiply by 0.02. You're gonna multiply by 1 minus 0.02. Because your rate of growth and decay, when you put it into the equation, always gets either added or subtracted from 1. You start with 1 and then add or subtract. Never use the percentage itself in the problem. I'm not using 8% in this problem, I'm using 0.92 in the problem. All right. One more, and then we'll look at yesterday's quiz.
Yeah.
Suppose we have 100 bacteria, we're putting them into a petri dish, and the culture doubles every hour. Predict when the population will be 350,000. All right, let's write our equation first. So we're gonna write an equation that looks like y equals a times b to the x. So y equals, what's my initial value? How many bacteria am I starting with?
100.
100. Now, my population is doubling, which means it's going up by 100%, right? So I had the original 100 and then another 100.
2.
So this is 2. Right? 2, I'm doubling, 2 to the x. And it says predict when the number of bacteria will be 350,000. I see a bunch of you typing away, that's awesome. What are you typing? What are you doing?
Divided by 100.
First you're gonna divide by 100, okay? So now I have this equals 2 to the x. Now what? Log both sides. Now, did you already do it? Okay, I'm gonna, just to show you it doesn't matter, I'm gonna ln both sides. Now, I would normally use log, but I just want you to know it doesn't matter. So I'm gonna get ln 35,000 equals x ln 2. So I'm gonna divide this by ln 2, and I'm gonna do exactly what you got. What'd you get? 11.77, that's what I got. Moral of the story is, I don't care, doesn't matter, use whatever base you want, but 11.77. And what is that? Days? Hours. Okay, how many of you ever had food poisoning? This is what happens when you have food poisoning. 100 bacteria really isn't that many. But those little puppies grow so fast, then in 11 hours, now you got this many of them in you, and you're starting not to feel well. And just think in a few more hours, at the end of the first day, you're gonna have 700,000 of these things in you. Wow, no wonder you get so sick. All right, anyhow, that's that. Let's look at our quizzes from yesterday. Some of you did magnificent, some of you didn't do so well.